Welcome to Star Chat, the podcast where we explore the wonders of the universe and all its secrets. I'm your host, Carl, and I'm thrilled to have you join me on this journey through the cosmos. Today, we're talking about a major milestone in the search for life beyond Earth. You might have heard the news that the number of confirmed exoplanets has just surpassed 5,000, but what's even more exciting is that the total count has now reached over 5,000 and is rapidly approaching 6,000, with thousands more candidates waiting to be confirmed. These exoplanets are planets that orbit stars other than our Sun, and they come in all shapes and sizes, from scorching hot worlds that are closer to their stars than Mercury is to our Sun, to icy cold giants that are farther away from their stars than Neptune is from ours. The discovery of these exoplanets has been a game changer in the field of astronomy, and it's raised hopes that we might one day find a planet that's similar to Earth, with conditions that could support life. The rate of exoplanet discoveries has accelerated in recent years, thanks to advances in technology and new missions like the NASA Transiting Exoplanet Survey Satellite, or TES, and the European Space Agency's Gaia mission. These spacecraft are able to detect exoplanets by measuring the slight dimming of a star's light as a planet passes in front of it, a technique known as the transit method. But finding exoplanets is just the first step. The next challenge is to determine whether these planets are capable of supporting life. To do that, scientists need to study the atmospheres of these planets, looking for signs of gases that could be produced by living organisms. It's a tough task, but one that could ultimately lead to the discovery of extraterrestrial life. NASA's James Webb Space Telescope has already made some promising discoveries in this area, analyzing the chemistry of over 100 exoplanet atmospheres. And future missions, like the Nancy Grace Roman Space Telescope, will be able to directly image exoplanets and study their atmospheres in even greater detail. The search for life beyond Earth is an exciting and ongoing journey, and we're honored to be a part of it here on Star Chat. We'll continue to follow the latest developments in exoplanet research and bring you updates on any new discoveries that might shed light on the possibility of life elsewhere in the universe. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat, folks. We're diving into the fascinating world of space exploration and asteroids. You know, those tiny rocks that float around in our solar system can be pretty mysterious, but also really interesting. Today, we've got a story that's out of this world, literally. So, you might have heard about Japan's Hayabusa 2 space probe, which has been making headlines with its asteroid-hopping missions. Well, it's on its way to visit another asteroid called 1998 KY26, and let me tell you, this one's a real tiny titan. Initially, scientists thought it was around 100 feet in diameter, but new observations from the European Southern Observatory's Very Large Telescope have revealed that it's actually only about 36 feet wide. That's smaller than a school bus, folks. Now, you might be thinking, okay, so it's small, what's the big deal? Well, here's the thing. This asteroid is rotating really fast. One day on KY26 lasts only 5 minutes. And get this, the Hayabusa 2 probe itself is almost as big as the asteroid. Can you imagine trying to land a spacecraft on something that's basically the same size as the craft itself? It's like trying to park a car in a tiny spot. It's going to be a challenge. The scientists are excited because they've never seen an asteroid this small up close before, so they're not really sure what to expect. Will it be a solid rock, or just a bunch of rubble held together by gravity? The possibilities are endless. And the best part is that even if the Hayabusa 2 probe doesn't make it back with samples, it'll still provide us with valuable data about these tiny space rocks. You know, this story got me thinking, what if we could use this technology to explore other small asteroids that might be hurtling towards Earth? We could potentially prevent another Chelyabinsk-like incident where a small asteroid exploded over Russia and caused some serious damage. The implications are huge, folks. So, there you have it. The tiny but mighty asteroid 1998 KY26 is getting ready for its close-up with Hayabusa 2. Stay tuned for our final story of the day, right here on Star Chat. Welcome back to Star Chat, dear listeners. As we conclude another fascinating journey through the cosmos, I'm excited to share with you a remarkable discovery that's shedding new light on the formation and evolution of our solar system. Imagine a distant star, similar to our Sun, that has burned out and collapsed into a white dwarf. This stellar remnant is now pulling in objects from its surrounding Kuiper belt, a region of icy bodies and small celestial entities. Using the incredible capabilities of the Hubble Space Telescope, a team of scientists has detected a white dwarf approximately 260 light-years away that's accreting fragments of a dwarf planet. This exopluto, as they call it, is composed of 64% water ice with a significant fraction of nitrogen, the highest ever detected in a white dwarf debris system. The implications are profound, offering us a glimpse into the potential fate of our own solar system billions of years from now. As we explore this phenomenon, we're reminded that the universe is full of mysteries waiting to be unraveled. The discovery of this icy and nitrogen-rich extrasolar planetesimal provides valuable insights into the building blocks of planetary formation. By studying white dwarfs and their accretion of volatile-rich objects, scientists can better understand the frequency and composition of these events, ultimately helping us learn more about how water is delivered to rocky planets. As we gaze up at the stars, we're not just admiring their beauty, we're also trying to comprehend the underlying mechanisms that shape our cosmos. The Hubble Space Telescope has been a stalwart companion on this journey, making groundbreaking discoveries that continue to reshape our understanding of the universe. With its legacy, we're poised to embark on new adventures, exploring the unknown and pushing the boundaries of human knowledge. That's all for today's Star Chat. Remember to like, share, and subscribe. And, until next time, remember to keep looking up at the stars.